All right, so today we are going to be doing 9.1, solving quadratics by graphing. And so the goal here is to just basically use what we were doing in chapter 8 to help us solve these quadratics that we've been working with. And so the way that we're going to do this, and just to kind of give a preview of what we're looking for here, is if we know how to graph a quadratic, I'll just draw just a generic graph here. So if we know how to basically graph something, let's say we got these as our points here, and we come up with our answer to the graph of a quadratic, we should be able to look at this graph and actually solve for x. And basically what we're going to find is that the point where the graph crosses the x-axis is going to contain our answers. So we're going to end up with two answers for this one, where x is equal to -2, or x is equal to 0, right? So the only way that this works, though, is first we have to set the equation equal to 0, because this line actually is describing what the equation is, what the answer is when y is equal to 0, right? This whole line represents when y is equal to 0. So if we can set the equation equal to 0, then we can go from there and actually solve for the 2 points where it's crossing that line, okay? So let's start with the first step. Or actually, let's write out all of the steps. Steps to solving by graphing. Okay, so number one, just like I said before, it's not going to work unless we set the equation equal to 0. So first things first, we got to set our equation equal to 0 before we can actually solve or graph it. Okay? Number two, we're going to find the vertex. Okay, so when we find the vertex, we need to remember how we find the vertex. And remember that the x value is always going to be equal to -b over 2a. Okay? And then once we've got that, we kind of have a step within a step. So we kind of have two steps here. First, we find the x value, and then we plug in, we'll put a comma here, plug in x to solve for y. Okay? So two steps within step two, we got to find the x value by plugging it into this formula, and then we've got to plug in the x to find the y value. Number three, we need to find a second point. Because remember, we can't just graph just knowing what the vertex is. We need to actually know what that second point is as well. And so here are my two options. Let's talk about option A. So option A is going to be to use the y-intercept. Okay, so that's my first option. Instead of trying to plug in something and solve for it, I actually know what my y-intercept is. And for a quadratic function, oops, not 3, my bad. Let's scratch that out. It's always going to be 0, c. In my head, I was saying c, but I wrote 3 for some reason. So here we have 0c as our y-intercept. And as a frame of reference, let's go ahead and go back here and let's actually write down what we're even referring to. So this, if we can remember, is a quadratic function, right? So if we have this, we're going to be using this information to solve for all this. This is where the -b, the a come in, and the C value comes into the second point. Okay, so that's my option A. Now let's talk about option B for a second point, because sometimes I don't really like using the C value, because what if the C value ends up being something huge like 54 or 108? That's not going to be super fun to graph on a graph like this, right? And so instead of using that, it might actually be better to pick a different point. And if I'm going to pick a different point, I'm actually going to pick or use a point close to the vertex. Okay? So we're going to use a point close to the vertex. And if I do that, then I need to pick an x value close, plug it in, and solve for y, right? So for example, if I got my vertex and my x value ended up being something like -5, I might want to choose something close for my next x value, like -4 or -6, something close by. That way when I plug it in, I get a y value that's semi-close, kind of close to what I got for the vertex as well. And that way I'm not graphing something crazy. We can see that here I purposely plotted 2 points that were really close to the vertex, right? A little bit easier to see what's going on that way too. Okay, number 4. Now we're going to reflect the second point across the axis of symmetry. Okay? And if you're wondering what that is, because you might not remember at this point, but the axis of symmetry was always just the x value of the vertex, right? So whatever you got for the x value of the vertex, that's going to be that straight line. And here you can see that if I were to draw an axis of symmetry on this example, it would be this dotted line that doesn't actually exist, but I kind of write it in just so you can kind of see what I'm talking about. It's that mirror point, and we're going to graph one side and then go to the other. That's kind of what we're going to do, okay? And then finally, last thing we're going to do is after graphing or after connecting the points with a parabola. So remember that parabola is just the shape of what we have here. So we're not doing straight lines, right? That would be absolute value, but instead we're doing a parabola. We're giving it some kind of bend, right? After we've done that, the next thing that we're going to do is we're going to identify x by the points, and we'll put a parentheses around the s here, because it could be just one point or no points, and we'll talk about that later. Where the parabola intersects the x-axis, okay? And that's exactly what we've done here. So if after I've drawn my parabola, what I'm going to go and do is I'm going to identify the x value by the points where it crosses the x-axis, right? And so these end up giving me my x values at the end. Okay, let's do an example.